So now we need to start from very beginning the project 3D model for pancake baking. So it means you have this mechanism. Automatically it should closing by needs automatically up. Now switching this position, and here the harness going to the pump, the mass into the bottom part, and the mechanism after goes back, closing, baking, particular time, opening, and after rotating, so and placing on the table. So this is should be going automatically. The similar model is done before older, but very bad view it was. So 2 months ago I started this project, and from the start we need to preparing in better view. It means from aluminum profiles everything. So the question is how we need to solve it. It's everything connected to the special connectors. Here you can see it simple. The motors here. I use another one in 2 weeks for the full design. This is the motors and so on. From, this is the motors, the stepper motors, and this is the calculation for the position. So, and it means that it's loop, that closed loop motor, and directly from the Arduino module it could be controlled. From very start we're doing the bottom part. The bottom part, the plate, we're starting, and for that purpose we need to use the aluminum profile. So this, if we measuring, this will be 20 times 20 millimeters, and the size of the plate, it starts, if you opening the plate, is 400 times 450 millimeters. What it means, so we can starting new part, and for the beginning creating the plate. Example, choosing top plane, click to the sketch, so and we could drawing the form like this for edges, rectangle, and placing after the measurements directly. So and placing the left side, the 400 millimeters, 400 and enter, placing second one, and this 450 millimeters. So this start sketch, and now we need to doing some thickness, extruding, and the good thickness, it is 4 millimeters for the aluminum plate. So now you see this plate, and now we saving it, the new name, we starting from very beginning. Okay. Plate 01. The next, we need to adding at the bottom side the aluminum profiles, 20 times 20. So for the creating the plane, for the creating the sketch, we need some time for that. If you look into the how looks it, but we could doing some else. Example, if we opening this file, opening the sketch, how looks it, and you see I need some time for drawing it, but it is not necessary if I can find in somewhere in internet this sketch. And now directly we trying to find it. Opening the internet browser and searching. I know that is profile 2020 and it's from aluminum. And of course I need SolidWorks drawing and trying to searching it. So SolidWorks and download. Searching where we could find it. Maybe here, maybe here. So aluminum now. Okay, trying to searching. Grab CAD, yeah, I use this sometimes. So the similar profile and faster will be if I downloading directly. I could connecting. Okay, go to the library and searching. Example, profile 2020. 20 twins by the x-axis 20 millimeters and by the y-axis 20 millimeters, 20 times 20. So now we can find it. There is the holders for this profile is different. And we could search directly. This profile, aluminum profile 2020 example. Oh, good. It is enough. And we need to check or the format is designated for the SolidWorks. SLDPRT, it means for the SolidWorks. Click to download. Preparing, waiting some time. And it downloads. Okay, we open now this. File. I'm going to this place it. Now unzipping. And we have this file. Now we need to open this file in the SolidWorks software. Closing the old document and opening this part. Okay. I have aluminum profile on this. Opening directly. Show that it's made with educational version. So now we see that we have this profile, and if we look here how it's drawn, started with this form, after cut it, fill it, and cut it, and so on, and at the end you have this profile. So the best choice, if we saving or naming this under other name, That for us is better. And we could saving, for example, bottom 0, okay, bottom 2020 and 01. Now we need to check the length. This could be full length. We have 450, the biggest one, length, and we could change the length by our needs for 450. Assign it and save. So now we have the plate and created the part for the bottom bigger length. So what's next? We need to create the assembly file. Make assembly. So now if we open it, this two parts here, you could click on the left side on the menu and place somewhere inside the assembly file. So we have one part. We need to add another part. Insert components, click to assembly, insert components, and choosing the bottom 2020 and 01. Click here and place it. But we need to add another one. Insert component, bottom, and we have double this part. Good, we place it here. Now we could save in this file. This file is assembly file. You can name, okay, assembly 01 in the same catalog. That's okay. Change the name. Rename the assembly. .1. So now we need to doing the mates between these parts, and for the beginning we need to click to assembly menu and mate. So now we can choose the bottom part of this plate and top part of this element. And if we rotating, you see that it's good matching, and we agree. The next it is we need to doing the same with this part, but we could now creating the mates with this. This should correspond the mate to this. Maybe both are here, yes. Good. And now if we moving one element, as you see, it could be moved. And yes?
Why do you make specifically those areas that you pressed? Or is there no difference? Can you just choose whatever area?
No difference. It means you could mating here, this plate side, yeah, you means with this, or separately this, yeah, about that. Yeah, this is not so important, but mostly the same parts I doing. Well, if I need to moving in the future, I need to moving all these parts together. It's better for me. while to outside element, like to the plate, it is only one link, only one mate is done with this. And I don't need to cutting or breaking the mates with this if I need moving both parts. It's better for me. So now I need doing some rotations and doing another mates. For each part, we need to doing 3 mates always in 3 axes. Choosing another one mate. And you could mating this side and here, this side of these 2 parts. Increasing, I click to this surface and this. And checking. Is that good or not? So you see, it's good or not. From my viewpoint, it's bad. I need to rotate it 180 degrees, and well, I choose it this, and this should be on the bottom part. I need to change it, means mate alignment. I click to here, and it changes. So it changes now, and now it's much better. So I agree with this. The next, I need to do the same with this. And of course, I'm mating these elements between this and this together. But okay, now I could do like this and checking is good or not. Not. I need to change the alignment. So now it's good. The alignment. I agree with this. And now, if I can move it, so but I need fixing. So I can't move sides, I can't move to the top and down, but I need mate this surface and this surface. So looks good. I agree with this. The similar I can do here, mating this and this. And now checking everything is good. So the next I need to add another one, but with particular length. And length will be another, not 400. Well, full edge is 400, and we need excluding this and this length. Okay, if we know the precise measurements, like 20 and 20, it's okay, we could calculate, but sometimes we need to measure the distance between 2 parts, and I show how it will be better to do. Need to click to evaluate, click to measuring, and choose the surfaces between I need to measure it. This surface, click with middle mouse button, rotating this part until I can see another surface with the wheel increasing, decreasing, and click to this surface. So now I see the dimension, the measurement, and distance is 360 millimeters. So this length I need to create another part. Okay. Now I could open this part, click to this element, or I can click here and opening it. I open it. What's next? If I changing the length here, directly changes in the assembly file, the first part. But I need to saving under another name. And example, I saving, and the SolidWorks ask, I need save this document, I need doing copy and continuing with this drawing, or I doing the copy and open new one part. Mostly I doing the last one. Click to the third one option, and now I change the name. Example 02, and click to assign. It saves. For instructions, okay. So now it's a question, I need to keep the old document or close it. Of course, I need to close it. I don't need anymore the old one document, and leaves only one new one. So now I need to change the length. We measured the length for 160 millimeters. We could see how looks our sketch, but we don't need it. We need to click to the with left mouse button on the boss extruder, and after in the automatically shown menu I need to click edit feature with left mouse. So I'm waiting, and it opens the parameter for extrusion, and I need to change it. I write 260 and enter. Shorter. Now I could save it and opening the assembly. And I need place two elements with another edge. Click to assembly menu, insert components, and second one, part of 2020 profile. Click one more time here, and one more time I could opening, or I can doing another way, not click to insert components, well, the same part I could simple copying. Click here, Ctrl C, Ctrl V. So it's done, second one, in the same place. If I click here and moving, so you could see that is two separated parts. So if I try to move this element, I can't move. If I try to move this part, I can do. If I try to move this plate, I can't move. Why? Not. The first plate, the first part that I place it into the assembly file, this part is fixed automatically. If you see the letter F here at the very beginning before the name, this means it's fixed by the coordinate system. If I click on this and right mouse button, I have additional menu, and I could change the fixation to float. I click to float, you see disappears F letter, and now I can move all these parts together. So this is very simple. If you placing the another one element, or you could fix everything. Example, if you fix this element. If you mating, all parts will be rotated by this part only. This part is fixed, I can't move it. But it's not so important at the beginning. And mostly I doing the main part, like the plate, better doing with fixation, fixing it. But I need to, of course, remove the fixation here, float. So now we're trying to mating these parts. Click to mate. So now click to one surface, this part, with middle mouse button, I click and change the angle, and mating, need a second one, surface and mating here. And I need to check, is good or not. Looks good. I agree here or here. It's the same. Automatically it's empty new one. I click here and click here. Sign it. Good. Now I need to create this and this surface I need to choose. So it's made it here, and the last one I need made this surface with this surface. So now I have a good connection here. I need to place the fourth one element doing the same. Example, click this surface and this surface. It's placed here. Good, I agree with this, and increasing scale this surface. Is this? So so now we've done the first assembly, but it's only the plate. So we need to create another one assembly, or on the same assembly placing another elements. If we opening the old project, so we could start with the bigger profiles, 40 times 40. So, and you need to find at the beginning this profile in internet. So we try to search it. Profile 4040. Click this. Oh, it is a lot of elements. But we could downloading it. Place in our catalog. Extracting it. And need to open and find which part is okay. We opening through the SolidWorks. Click to Control O, opening it, and look. So this is good. This we need to use. Opening. So we have the profile. Now we need to save it under new name in our catalog. .01. So now we need to know the length. This length is, so remember, 25 millimeters. We need to measure it. show only area and perimeter, but if we click to the one edge, for example, it should show the length 250 millimeters. Good. Open with Control and Tab another file, and we change the length of this. Click on this element, edit feature, and adding the length 250 millimeters. Signing it and saving. So now we open the new assembly, and we need to place it. Assembly, insert component, and the profile 4040. Place here. What's next? We need to know the place where we need to place under this table, on the top of this table. So, and we need to know the measurements. For the first try, we could click the simple two mates at the beginning, or only one, and after we need to add in another two. So now we could creating the mate, this table part, this surface, checking, good. And now we could move in this position, but always is attached to here. That's okay. I click to escape. So now it's good. Assigning it. So if I moving it, moves here, but always is touching to this surface. Good. What's next? I need to place something. For that purpose, the best choice is if I opening this plate and placing the hole. So the hole in this plate. Example, I click to the sketch, choose this surface, and place somewhere the hole. It's not match which diameter we have, but we need to measure here the measurements, adding measurement example 200 and example here 100. So good, now we can click to the feature and click to extrude that cut. So now we could see the feature, and the best choice if we click to the hole, doing this hole and cutting. So it appears good. Opening back the assembly, we see here. So it's not okay. I need to see where is the 400, where is 450 millimeters. So we know that 450 millimeters is this element, but I need to change the place. It means I need to move somewhere here, and starting from, if we opening this, so this is somewhere here, but the place we could checking. Click to evaluate, measuring, click here and click here, this edge. and now show 179 millimeters. Okay, we could do 180 millimeters. 1 millimeter is not important. But we see that we need to change from this edge 180 millimeters here, and need to change the maybe measurement from here up to here. After, so go back, opening this arrow, the sketch, click to sketch, click to edit sketch, and we need to change the position. We placing at the beginning 180 millimeters. Good. What's next? Checking it. So now good, but we need to go to this position, and we need to measuring it. Again, we measuring it from this surface up to this surface. We have distance 111, and of course we could reducing 1 millimeter, and it will be 110 millimeters. Okay, opening this part, and we need place not here, not there, but we need from this side. It's rotated 110 millimeters. Okay, exit to switch, save it, opening this. So now it's much better. Good. What's next? We can placing into this hole position the matching or the axial position of this element. If we have here circular element, it's the best choice. Okay, we could check it. Yes.
And then you change the whole dimensions for the resource?
Yes. It also moves the part, the position changes. If we changing the position on the plate, this hole, I will show to you. Okay? So now we're trying to mating it. We don't know exactly, or we have the circular element here inside or not. We don't know that. Looks like circular, but it's not clear now. So we could check. Simple click to the assembly, mate, click to the hole here, and try to click somewhere here where it has circular surface. If you see that concentric assigns automatically the mate, it means this is circular surface, and it's very well done. Good. I could assign it. So now you could see that in the same position that we need, it's placed, but we could rotate under this axis. How? Change it. So we need to mate the surface. The third one mate we need to do for this, while we have only two mates before. We have the cylindrical to this axis, to this hole, and we have on this plate the bottom part of this profile. Now we need to add the third one. Third projection, third mate. How are we doing that? We are choosing this surface example and this surface. And what happens if we click to coincident? We have the error. Well, we have place the mates in this hole. But automatically the system chooses it parallel. This I agree with this choice, and we could assign it. Now we can't rotating and can moving. Good, save it. What happens if we change the position? Of course, I see this is too small position. I need to move to the left side if we opening the older one. No, that's sorry. Yeah. I measured, especially I measured from this surface up to this surface. Is the simplest one example to measure. It's much difficulty to measure between the average, the middle position of this. Well, I don't have the middle element, but I know the measurements. It means I measured between this surface and this surface, and place the hole, and between this surface and this surface. And I need to add 20 millimeters to this position, 20 millimeters to this position, to the center. And now I could open this plate and try to add 20 millimeters. How I could do that? Changing to 130, yes? Good. But it's another question. Like, okay, one time I'm changing like this. 130 millimeters. Click enter. So it's change the distance. And the next, I saw I need to add additional 20 millimeters, but click 2 times to this element, and I could adding 210 millimeters here, changing it, or I can doing mathematical function doing plus 20 and click to enter. It automatically calculates. While this is important, sometimes it's difficult to remember if you have 4 or 5 numbers in the value. Or sometimes you need divide by 2, multiply with 2. You need to care about it and to calculate very precise. The best choice you could adding elements plus, minus, divide, multiply, and so on, and assign it. Good. Now exit from this part, go back to the assembly, and it's automatically moved. This part 20 millimeters to left, 20 millimeters to up by this picture. So, good. The next, but we need to add additional 2 elements. We need to check or is the same length or not. Of course, this is the same length. We could see this and this additional. Now we placed this part, and we need to add this and this. But it's the same length, it means the same part I could adding. Ctrl C, Ctrl V, and again Ctrl C, Ctrl V. I have 3 parts. But all these 3 parts in the same place. If I don't know how many parts are here, or sometimes parts, of course, not by click Ctrl C, Ctrl V, copy, paste, but sometimes if I inserting components, the placing, for example, 2,000 or 30,000 millimeters away from this part, and I don't see the part. In the SolidWorks, there is the one beautiful button, F. If I click to F button, it automatically show all parts into one window. Part that is marked here, I could move by this arrows. Here, that direction. And the example I showed to you, if I move to this part somewhere here, and I don't know where the part is placed, I see this part is here, the centrum. Click to here, I don't see nothing. Of course, I can increasing, decreasing, but best choice, click to F and show the part. This. All parts shown in the one screen. And I can move. Near is better to recognize and to understand. You change the position, the height. Click to this part. I saw changing the positions. So I have 3 parts. Good. Now I need to place 2 parts here, but I need to measure the distances. Good. Now we could click to the evaluate, measuring, and measuring this and this distance. And I see few measurements. Normal distance 61 millimeter. Good. By x-axis, by z-axis, by y-axis. Shown everything. Good. So it means the 61 millimeter. Good. Now I rotating it and I need to place 61 millimeter away. Assemble, mate. At the beginning I place on the top of this surface, mating this and this. Assign it. Now I can mate this and this. Not this. False. Where is my... I can move this. I can move this, but I can't move this. This is placed fully. Okay, I need to rotate maybe to better understanding that the mate directly with this picture. So, okay, go doing the next point. This I could move somewhere, but I doing the mate. This and this mate. Good. The next, if it's placed, example, one onto another the parts, it's difficult to know which part is placed, which not. But best choice, if I click here on the left menu and I see the arrows and I can try to move it, I click to this, not this I need. I click to this. To this, you see 2 parts are on the same place. But I don't know which is placed one, which not. I try to move it. I can do it. Good. It means not this part I need. I need this part. Okay, this part. I try to move. Yes, it moves. And now I have the mates. How many mates I have? 1 or 2 of this part. If you don't know, we need to open the list. Click on this element here or this element here and click to view mates. And I see now we have 2 mates. Simple moving the arrow to the cursor to this, I see that the pictures show that this bottom surface of this profile is made with this. You see the different colors. And I move to another one, it is made here. This is good, it means I have 2 mates. And I need to do the last one mate. And I'm doing the mate between this and this inside. And click here to the distance and write 61 millimeter. And assign it. So now I could check. If I open view mates, I see 3 mates, coincident, coincident, and distance. And show between what parts are placed the mates. Good. The next, what I can do, I can place this element parallel to this surface, and I need to know only the distance. The distance we could measure. Click to evaluate, measuring between this and this surface, and we see 71 millimeter. Good. Click to escape, reopening the older documents, and click to assembly, mating, and now mating this surface and this surface. It's good made. If it happens that made not so, but like this, it means you need to change the mate alignment. It could happen. About 50% don't matching the alignment, while system automatically should. Good. Now we assign it, and we need to move this part. Click to this part, move part, and we need to add the distance between this and this surface, 71 millimeter. Click to distance and 71, enter. Good. And how many mates we have here? This profile, 1, 2, or 3. If we try to move it, we could understanding that is not fully mated. If I try to move this, I can do. If I try to move this, I can do. Try to move this, and so on. The best checking elements of mating is try to move it. Click with left mouse button and try to move. I can do that. Good. It means I need to doing the mates. Now I need mating the bottom surface of this profile with this plate. Okay, click to mate, click to this surface, and how I can catch this? If I don't see if it is inside placed, I can move this part. I can click with this element, so, and I could check, try to move it with the right mouse click. I can move this part, and I need to choose increase the scale and click to the surface and check it. Good. Now we positioned well this 3 elements. The next, what we need to add inside here 2 elements, the same length, on the very top and not at the very bottom, but in some distance. We need to create 2 parts with the same length, and the length was 61 millimeter between these 2 surfaces. Okay, now we go back, open this part. From this we saving as another part. And again click to the 3rd option, and we could use the 02, the name, close the original document, we need a new one, and now we need to change the length. The length should be 61 millimeter. 61, enter. Good. Assign it. Save it. Go back to the Control and Tab, or the same as here. We could choose our assembly, and we need to place somewhere here. Insert component 02. Place here, and one more second part here. Good. We have to. What's next? We need to add in some mates. At least 3 mates for each part. Here, here, and the bottom, the top, sorry, surface example, and we need to check is good or not. Not good. This should go inside. between this. We need to change the alignment. Click here, it changes. Good. Now I agree with this alignment. The next, I need to make example this surface with the nearest this surface. Check. Good. And the last one, I need to place, make this surface and this surface. Good. Now I can check, if try to move, I can't move. It means fully positioned, fully made. If you fully mated the elements, you see disappears the minus symbol, the minus sign from the very beginning of the file name. You see this part is not fully made, not fully placed, not fully mated, and there is, yes, the minus at the very beginning of file. So we need to mate this. To mating, click here, and here. Check. So I agree with this. The next, we need to mate this and this surface. Good, looks not bad. And the last one, I need to check the height, where I need to mate it, and I need to measure it. Example, click to evaluate, measuring from this surface up to this surface. Can't catching it. Okay, again measure. Now it's good between this and this. And I see distance, yeah, it's not even, but of course we could change it. 44 millimeters. Open this file, now assembly, mating, rotating, that we could see the bottom surface, click to this surface, and click to this surface. And distance 4 millimeters. So now mated this element. The next, we need to create new one element between these two parts. So between these two parts, and this is inside placed this element. We know the length, the distance between two parts is 71 millimeters. We need to add one element, 71 millimeters. Open this. We could open the last one, element, saving under another name. Example 03. Close the original. So now we need to change the length. Changing the length for 71, enter. Assign it and save it. Good. Now opening the last new assembly, and we need to place here inside. Insert components, profile 03, place somewhere here. Good. It means the part length we need to change by our needs. For example, I'm measuring directly. Well, you could doing here, but it's still the same. You opening in the same way from assembly file, opening the part, and you could measure here distance but so and so separately are showing that simpler to understand. Directly here you could open. You could open edit part directly in assembly, or you could open part separately. If you click to edit part here, you see whole assembly. Like it's clear, and you could change directly. It's the same as you're doing the separated. So you could change it, but I'll show that it's not fully designation. 81 millimeters, simply changing. And we need to exit here, exit from the editing of part. This is still the same. So now we need to mate it. Mating this surface with this surface. Good. If I need to move, we could move it. Now I'm mating this surface with this surface, and this surface with this surface. Good. And I see that not matching together, and this is too long, this part. So I can directly opening here, click to the part, and if you click to edit part, directly in the assembly you could editing or opening separately. Click here, click, you see the color changes of this part of all tasks, and we're changing, okay, minus 10 millimeter doing. So, and now is good position part. I try to move, I can't move. And this appears minus symbol at the very beginning. So what's next? Next I need to add another one long element. You see, now is between these two parts is only one this, but from the side it's this element placed. So we could check the length of this, click to evaluate, measuring, and click to the one line. The length 245. So now opening all the part, we can save under another name. Well, we need to have another length 04 and save it. Close the original and change the length 245. So, good. Now I opening the new assembly, and I need to place here assembly, insert component. If I don't see in the list here example, okay. If I don't open it, this part, I closing all parts. Closing one part, I have old assembly and new assembly. I need to place this part, but I need to know for that propose the name. Insert component, and in the list I don't see this. Of course, I need to click to the browsing, and from my catalog I need to choose the parts. So I need to know which one, what the number is. Of course, the last one. Opening this and place here. What's the next? I need to place here mating this surface with this surface. It's good or not? Not good. I need to change the arrangement. So now it's good, this arrangement. What's the next? this mating with this. What happens? Also is wrong. I need to move it. The best choice, click to parallel. It means you could move, or click to the distance. And you could move apart this edge like 50 millimeters. So you see it's wrong direction, distance. You could click to flip dimension. So now it moves to another direction. And we rotating from the top view, so looks good. So we need to position. I don't know how many millimeters should be placed here. The 50 I placed, but of course we need to measure it. So from this position we need to measure between this surface and this surface, the distance. Click to evaluate, measuring this and this. I rotating, so and I see this dimension. 49 millimeters. Okay. Open this. So now I need to find this mate. The one possibility I can click here. I have two mates. Another one possibility I can click here, all mates, and try to search it. This go by the order, the last one. And I need to edit feature and change this distance to 49. Good, it moves 1 millimeter. So the next, I can move up and down. Again, I need to measure the distance from the old assembly, from this surface, example, up to this surface. And I see distance is 150 millimeters. I can move by needs, sometimes into the same place, placing 3 or 4 measurements. You could move with the left mouse click 150 millimeters. Good. Click to escape. And now we need to mate it 150 millimeters between this surface and this surface. Assembly. And you go back, and you see now this one minus, not fully mated part. You see minus symbol. Click to mating between this and this surface. So automatically it's created the mate type coincident. You could click to parallel, perpendicular or other, but you need to have distance. 150 millimeters. Enter. And assign it. Good. Now it's much better. What's next? So we need to add the fixing elements, the fixation elements, and the caps at the ends of this part. So we downloaded the SolidWorks files for the profile 4040, and here inside it is the cap. How we could see it, the best choice from the SolidWorks opening, Ctrl O, and check where here profile, where is our cap. Here, not this, not this, not this. Checking this cap. You see, good. we opening this cap. Now we could saving under another name and placing in our home catalog. Click to this catalog and cap 01 or cap 4040. Good. Now close this, and we need to place everywhere where we need to add the caps. Insert components, browsing, and search with the cap. Place here. Good. How many caps we need? 1, 2, 3, 4, 5 caps. We could click here and 4 times Ctrl+C, Ctrl+V. 3, 4, and 5. So now we have 5, but it's the same. All has the same measurements, the same sizes. But now we need to place in the right position. We click to the mate, click to the one surface to another surface, and check is good positioned or not. Now we see here is good, but here not good. We need to change the alignment. Click here, alignment. Now is more better. The next one, mating this surface with this surface. So not bad. But we need to add additional one turtle mate. We could, with the mouse left button, move it away and click to this surface and this surface. So now it's fully mated the cap. We could try to move, but we can't move this. And disappears the minus sign. The next cap, again we need to mate in the same way. There's one surface here, one surface here. Changing the alignment, so now it's good. Now find the surface, this, and click to this. Good, and you need to change the height. The third one mates this mating with this surface. So now it's good. Mating another one. This surface, this. Check it again. No, not well. So it's much better. But you see inside somewhere is placed. By needs we could check which one. This is element. With the arrow we could move. So now mating another surfaces. This surface with this surface, much better. And the last one made this and this surface. So now we have 3, doing another one, this surface to this. So not well, I need to change the direction, changing the alignment. Good. Now click to this surface and this surface and this surface and this surface. So now it's fully mated. And the last one is with minus. You could see, if I can see, so I can click the F button appears all parts inside, and mating the last one cap. This surface. With this. Is good or not positioning? Good. Now this surface with this, and this surface, this. Here is two surfaces. If wrong, you could click to this text, deleting it, click with the delete button in the keyboard, or with right click you could delete. Okay, again, that's wrong. Okay, this surface and this surface. So now we see fully mated all parts. So this is for the very beginning.